Recognized software for building physics and static calculations of glass, windows and facades. Software for your success. sommainformatik.com.
Welcome to today's webinar with the topic WINSLT. My name is Sebastian Hinmuller and today I will present you our product WINSLT. For the next 30 minutes or so, we will first look at the topics on a PowerPoint in general and then we will go into the software and look at the points in the software directly together using examples. I will now deactivate my camera so that you can concentrate better on the presentation. What's it about today? It's about WINSLT. WINSLT is a software from the company SommaInformatik and we use the software to calculate the heat transfer coefficients, solar radiation and the light transmission coefficient. What does WINSLT stand for? WINSLT simply stands for solar light transmission. Let's take a closer look. Firstly, we have a validation report for WINSLT from the IFT Rosenheim. This means that the calculation methods and the calculations that are shown in WINSLT have been certified and validated by the IFT Rosenheim, confirmed that the calculations are also correct. Which norms are the basis of WINSLT? On the one hand, we have EN 673, which usually deals with the calculation of the UG value. What is the heat transfer coefficient for the window? We also have EN 410, which calculates the solar values such as transmission, reflection, and absorption, and EN ISO 52022 Part 3, which we use in WINSLT mainly for calculating the temperature distribution and then also for calculating the slats and the shading. You can start WINSLT in Somma Global. WINSLT is a part of our Somma Global, our large product range, where you also have parts such as Glass Global for the statics or WinTHS for the thermal stress. The call is made here via the respective buttons. Let's take a closer look at the program. Here we have a brief overview of the structure of the program on a slide. Here at the top are the results and the project data in the overview. On the left side in the green area, there is the master data, the spectral data which are delivered with WINSLT and then also updated with every update and adjusted to the corresponding defaults of the manufacturer. These update processes take place in a quarterly rhythm. We distinguish between the delivered data, which you can find here in the WINSLT tree, which I will explain to you later, and the user-defined data. Of course, you also have the option of importing data, creating spectral data, saving products structures, and these user-defined structures are then saved in a second database, which remains untouched during an update. That means we only exchange the spectral data specified by the manufacturers and your user-defined data remain unaffected. In this middle area, the structure is put together from the individual layers. From the base glasses, from the composite layers, of course also glass coatings and interpane spaces. This is then used for the calculation, and on the right side of the editor we have another detailed view, where we can see the positions that are currently being edited in the editor. Below this, the layer structure and individual or detailed information on the individual layers are also displayed. Here again, briefly, the difference between the delivered spectral data, the WINSLT data and the user-defined data. We have two material databases, two trees. You can also see the user-defined data here, which is all spectral data that the user can import via an interface, which they can save themselves and also manage themselves in this tree. Here is an overview of the special functions that are available in WINSLT, briefly mentioned here what else is possible. Of course, the normal data management, editing the data, copying, deleting, saving. Then, via a fixed interface, there are firmly defined pattern files, also corresponding instructions in the manual, with which you can import spectral data yourself, if you have spectral data from any manufacturer or also your own, which you can then import in this format. Then there is a gas mixer, with which you can mix any gas types in a certain proportion against each other, in order to then also define the interpane spaces. A calculation for vacuum, so you can also calculate vacuum glasses instead of a space between the panes. Define boundary conditions, i.e. any boundary conditions with outside temperatures and irradiances. Generate slats. You generate any slats with distances and inclinations from flat materials that are also stored in the database. I will then also give you an example in the practical part. Screen printed glass, i.e. you have the option of setting these printing proportions from a 100% printed and an unprinted glass and generating a new spectral data set from it, with which you can then also calculate a screen printed glass in WINSLT. Otherwise, everything else is processed using the folder structure, which should be clear as far as it goes. As far as the results are concerned, we receive a report sheet via WINSLT, where all the results are listed after the calculation. On the one hand, there is an overview of the layer structure actually used and structured according to the respective norm, the results for transmission and reflection, but also the UG values and the most important values outlined. Of course also the gtot value, with which you can see the total energy transmission curve. Then, as a second possibility, especially interesting for manufacturers, you can create a declaration of performance for a specific product, a specific insulating glass pane, or also for a specific coating of the glass. There are then some settings where you can then add layout or also signature and so on. CE marking, also in the context of the declaration of performance. Here you also have the option of creating a CE mark for a specific product as a PDF and outputting it accordingly. The interfaces between the individual parts of the program are also very important in the SOMA Global product family. When we carry out a calculation in WINSLT to determine the radiation results, we also have the option of transferring this glass structure one-to-one into Glass Global in order to carry out a static calculation, or to transfer this glass structure into WinTHS in order to carry out an estimate of the risk of breakage for the thermal stress. Then we start with our examples to give you a better understanding of the WINSLT. We start the WINSLT. As a hint, there is also a WINSLT ASHRAE. We are using the European norm. ASHRAE would be the same application, only according to US norm, the NFRC 100 and the ISO 15099. Of course, you also have an interface there and you can change to it at any time with your construction, which you have calculated according to the European norm. First of all, we start the editor for the WINSLT. We enter a description for our first position here at the top. We make triple insulated glazing and do the whole thing without a coating for the time being. It is important to define the system height again here, how high the glass pane is. This only plays a role for calculations where the transmission takes place via convection, usually for spaces between panes. The higher the system height, the different the behavior of the convection transmission. Here again is this separation of the spectral data for WINSLT, for the data we deliver with the software, and here the user-defined data. We now want to first put together a triple insulating glazing. That means we have here first of all a basic glass. I have stored my products under these individual rubrics: base glass, coating, etc. We want to take a planeable clear light from ACG Inter pane. I can select this here with a double click, and again with a double click, we want to make a laminated safety glass pane. To connect these two panes together, we need a laminated layer. We can find a laminated layer under a separate heading, here under laminated layer. Here I'll take the standard PVB, which can then be inserted here between the two panes of glass, and with a double click, there is also the option of changing the thicknesses here. We have the same option for a basic glass, so I can also change the thickness here with a double click. We reset the whole thing to the 4 mm. The next step would be a space between the panes. We would take argon here, 90%. So if we go here under the heading of gas interspace, there is an argon 90% here, which I can drag and drop into the middle or also take over with a double click. We want to use another planeable clear light as the middle pane. You have the option of selecting it from the basic glass again. Here with planeable clear light, but there is also the option of copying individual layers with copy paste. That means I can select the space between the panes here with the right mouse button, say copy, also possible with the abbreviation Ctrl+C+V, and then insert here with the right mouse button or Ctrl+V. Then we have inserted it here, we move it to the back. Then we want to make the final laminated safety glass pane at this point, again from 2 by 4 mm and PVB 0.76. I can also copy the glass pane here and insert it twice, then copy and insert the PVB film and move it to the right place. We would then have built our system, our triple glazing, at this point. We'll have a look at the result. We'll go up here and click on Calculate, and we can have a look at the results in the overview. Then you can see, of course, that the UG value is relatively poor here, because we haven't introduced any coating yet. If you go to the results, you can also see the overall overview of the construction. Of course, the temperature curve is also shown accordingly to the standard boundary conditions that we have set. The transmission line, that means the transmission for the UV range, the light transmission range for the UV range, and of course also for the solar radiation, that means visible light and solar radiation. Here is the reflection line. The line always means the rear side and no line means the front side for reflection. The absorption line for the individual glass panes, so the glass pane 1, 2, 3, outer pane, middle pane and inner pane. And of course the results for the UG value. For the gtot value, the total energy transmittance that is calculated. Why is the total energy transmittance here twice? This is because we calculate the energy transmittance according to EN 410 and then again according to EN ISO 52022. We now continue with the next example, so we save the whole thing up here. We have now saved our first item. Now we want to introduce the coatings. We just want to see how the whole thing works if we don't take uncoated glass, but we simply take a heat protection coating on position 2 and on position 5. We take our project, which we have just calculated without coating. Here there is the possibility to copy a position. For this there is a button Copy Current Position. We copy the position, so we have copied the original position again as position 2 here, and we call the whole thing with coating. We want to use a coating I+1, 0. Of course we also have the option of selecting the coating from the coating tree under coatings in this tree. But there is also the option of filtering these materials, which are available, using this search. This search not only goes to the WINSLT tree, the delivered spectral data, but also to your spectral data, which you have imported yourself at this point. We want to introduce a coating here, I+. If we do not enter anything else here, the system already suggests some coatings. We want to take that I+1.0, of course you can go here and say I want to display this coating again in the tree. So I can go here to go to via this button and get the display of this layer I+1.0 again, so that you can perhaps also see where it is in the tree. We use drag and drop again to move the coating to the correct position. The manufacturers often specify that certain combinations of coatings must be observed. So certain coatings only work on certain types of glass. Here you would also have the option to change the glass. We only want to insert the coating, and we are now doing the same with position 5. Our project 2 is now finished with the coatings, and you can already clearly see that the UG value, which was 1.6 earlier, has now been reduced to 0.5. If we look at the result again, we now have no change to the previous system, apart from the difference that we have now entered these coatings in positions 2 and 5. Of course, there have been significant improvements, especially in the area of the UG value, and of course also in the gtot value. Next, we want to provide this system with an external sun protection. I copy my system a third time with the coatings, and we now call the whole thing triple with external sun protection. What do we want to insert for an external sun protection? We want to insert a panel material. Panel materials can be found here below. What are panel materials? Panel materials are usually woven fabrics that serve as sun protection, but also as slat material or awning fabrics. We also have different manufacturers here. We want to take a fabric here, which can also be selected via the search. Awning outside. What I want to take would be my anthracite fabric, or if you know the numbers, you can also enter the whole thing up here. That would be 92047. Here we also find this fabric. We pull the whole thing into the system and want to have that as external sun protection. At this point, the system automatically suggests an intermediate space in addition to our surface material. We need a layer of air between the surface material and the actual glass, otherwise the calculation can't be carried out. And if you take a look at this intermediate space, we also have ventilated air here. This is air ventilated with a thickness of 5 mm. You can also change the distance here with a double click. We set the whole thing to 60 mm. The arrows that are indicated here show you which ventilation takes place here. With the right mouse button on the interspace, you have the option of changing this degree of ventilation. We either have the option of entering a free ventilation here. If you enter a free ventilation, there are just these different possibilities to define the directions. Where does the air flow from? Does it come from inside and go outside, or does it come from outside and go outside? That is the standard case. So we have outside air streams that flow in at the bottom and outside air streams that also flow out at the top again. You can set all of this here via these directions. Briefly, let's go back to the mechanical ventilation. Here you have the option of defining a mechanical ventilation via a volume flow and then entering it accordingly on the outside or inside. We'll stay with the ventilation for now. Free, outside, outside. Via these ventilation levels, there is also the option of saying whether I have a proportion of surface at the top and bottom that reduces or interrupts the ventilation flow somewhat. You can enter all of this here via these values. I won't go into it in more detail, that would be going too far. So we'll leave the whole thing at ventilation outside, and we want to calculate the whole thing here now. Then we get the calculation carried out here accordingly. Of course we have a clear drop in temperature here in this interstitial space, because we have outside air here that is also ventilated in. We take a look at the result. Here we get the results. The UG value can no longer be calculated here, because there is no UG value for shaded systems. But you have the calculation of the gtot values, for example, and at this point also the possibility to determine the FC value. I.e. the FC value is always set in relation between the gtot and the G values of the unshaded and the shaded system. In WINSLT there is the possibility to determine this FC value automatically, i.e. if I want to calculate this F- value here, the system does the following. In the background, the calculation is carried out, once without sun protection and once with sun protection. These two G values are then set in relation to each other. Well, as the next example, I wanted to show you a slats calculation. How can I insert a slats in WINSLT? To do this, we do the following: we save our system again and take our original system with the coatings and copy the whole thing over again. Now we calculate the whole thing with slats. I'll call the whole thing slats inside. We now want to insert a slats, that means I'll now go to this user-defined data. Here we have, as I've already shown you in the PowerPoint, all the functionalities with which you can then also create this slats. For example, how does the whole thing work? I first create this slat. We want to insert it under the point slats, so we select slat and go here to create a slat. Now we have to select a plane material. From which plane material do we want to create the slat? We will take a heller slat with a certain IL number. You can also enter the whole thing using these numbers. 5014, for example, would be a dove blue, which we will take over. In this slat geometry, you simply specify which slat widths we have, ax distances, etc. The inclinations are then also calculated and determined here accordingly. You can of course use this slat with different opening angles. We go here to OK, so we have created this slat, which is now also sorted under these slats, and with drag and drop we can now drag it back to the right-hand side. We get here again this intermediate space, which we can then also vary here accordingly in thickness, or also change the degree of ventilation here accordingly, which I showed you earlier. Here it would be inside and inside, we leave it as it is. Then you can calculate this gtot value again. Of course, the total results again, now for an internal slat with a certain axial distance or also a certain angle. Of course, you can also vary this slat in the closed state, for example. It's relatively easy by clicking on the slat here, right mouse button, and I have the option here to change this slat again. For example, here is an almost closed slat, so this angle alpha, for example, can be set to a minimum of 5 degrees, and thus we would have almost a closed slat. Then we can also carry out this calculation here accordingly. We save the whole thing again. Also again a short note on the results. What options do we have here with the results? You can, for example, also export these results as a PDF. There is the possibility here to save this result representation as a PDF via Export PDF. We can do that here, and we then receive a PDF. I can also move it to the middle here, a PDF file with which we can then, for example, send an email or send it to the customer accordingly. Finally, a note on the interfaces that we have all the functions that are available here. Here on the page under User Defined, I briefly showed you the possibility of carrying out a report of the spectral data. So we can import base classes, coatings, etc. using predefined spectral files, which must correspond to a certain structure so that this import can take place. The gas mixer, also explained briefly again, gives us the option of mixing the filler gas for the space between the panes in any ratio of argon, krypton, xenon, and SF6. That means we have the option here of mixing the whole thing by proportion or also by percentage accordingly, and generating filler gases for ourselves here. Boundary conditions can also be defined at this point. You can define your own boundary conditions. If you want to define outside air temperature, radiation temperature, calculate certain boundary conditions, certain temperature distribution, you have the possibility here to calculate these boundary conditions and then store them accordingly in the user-defined tree for later calculations. We have already looked at the slats. There is also the option of a vacuum, so you can define a vacuum here instead of a space between two panes of glass. And then, accordingly, insert this vacuum here, for example, and calculate it instead of a space between the panes. That is also a possibility offered by the system. Finally, then we are already through with the functionalities. Briefly explained is this representation of the screen-printed glass in which we have a printed and an unprinted glass. Here, of course, you need the spectral data. There is also the possibility of using a glass that you take from the database. For the printed glass we need an import of spectral data. For the entire printing and on the basis of these area ratios, a new glass or a new spectral data branch is then determined, which carries out these calculations for me on the basis of printed to unprinted accordingly. Finally, when we leave the system. For this, we take our system with the coatings, go to Save here, then we also have the option of switching to other products. So we can, for example, carry out a calculation in Glass Global Standard for our product that we have just created and immediately carry out a verification of the structural analysis, assuming we provided corresponding data such as loads and climatic loads, line loads, etc. Basically, it takes over the whole thing into the other system here, and the same applies to WINSLT ASHRAE. So I also have the option here of calculating the whole thing according to the American norm. Looking at the results here, of course you get slightly different values here according to the other norms that apply here according to the US norm. Then I've come to the end of my presentation. I hope you were able to take something away from the webinar. I would be pleased if you would take part in our webinars again next time. I would like to take this opportunity to wish you a good day. Thank you and goodbye.